Welcome students in this beautiful session which is a previous year objective question session 1. So today we will solve chapter number 7 alternating current most important objective question. In this objective session we have assertion reason questions also. So let's begin with the question number 1. In an AC circuit the current is in the phase with the voltage, leads the voltage, lags the voltage, any of the above depending on the circumstances. The correct answer for this question is fourth, any of the above depending on the circumstances. That means what kind of appliances we can use. Like in the case of an inductor, this will be different, capacitor and resistance. That may be changed, lead or lag. Second question we have, alternating current is transmitted to distant places at high voltage and low current, high voltage and high current, low voltage and low current, low voltage and high current. The correct answer for this question is high voltage and low current. Alternating current is transmitted to distant places at high voltage and low current. Next question we have, in an AC circuit containing only capacitance, the current leads the voltage by 180 degree, lags the voltage by 90 degree, leads the voltage by 90 degree, or remains the same with the voltage. The correct answer for this question is leads the voltage by 90 degree. In an AC circuit containing only capacitance, the current lead the voltage by 90 degree. Next question we have, a capacitor is perfect insulator for alternating current, direct as well as alternating current, none of above. The correct answer for this question is direct current. A capacitor is perfect insulator for a direct current. Next question we have, the value of induced EMF in an LR circuit at break as compared to its value at make it will be less, more and sometimes less. Nothing can be said. The answer of this question is more. The value of induced EMF in an LR circuit at break as compared to its value make will be more. Next question we have, an LCR circuit is connected to a AC source of a alternating current. At resonance, all applied voltage and the current flowing through the circuit will have a phase difference of pi by 4, 0, pi by 2. The correct answer for this question is 0. Next question we have, in series LCR resonant circuit, to increase the resonance frequency, L will have to be increased, C will have to be increased, LC will have to be decreased, and none. The correct answer for this question is LC will have to be decreased. Voltage across RLC are V1, V2, V3 respectively. Then the voltage of applied AC source is always equals to V1 plus V2 plus V3 under root V1 square plus V2 plus V3 का whole square, V1 minus V2 minus V3 or V1 square plus V2 minus V3 का whole square. So the correct answer is answer fourth one. Next question we have, in non-resonant circuit, the nature of the circuit for a frequency is greater than the resonant frequency is resistive, capacitive, inductive, none of the above. The correct answer for this question is inductive. In non-resonant circuit, the nature of the circuit for frequency greater than the resonant frequency is inductive. Next question we have, the correct graph between the resistance of the conductor with frequency is. We have an options in the graphical form. So the correct option is option 1. We have to show the resistance of a conductor with frequency. So we know that frequency remains same. The phase difference between the voltage and current in the LCR circuit is 0 always, pi by 4 always, pi between 0 and pi by 2. The correct answer for this question is between 0 and pi by 2. Next question we have, the phase angle between current and voltage is purely inductive circuit is. We have an options 0, pi, pi by 4 and pi by 2. So the correct answer is pi by 2. Next question we have, in an LCR circuit, AC circuit at resonance, the current is always in the phase with the voltage, always leads the voltage, always lags behind the voltage, may lead or lag behind the voltage. The correct answer for this question is always in the phase with the voltage. Next question we have, the average EMF during the positive half cycle of an AC supply of a peak value E0 is E0 by pi, E0 by root 2, E0 by 2 pi, 2 E0 by pi. So the correct option for this question is 2 E0 by pi. Next question we have, when an AC source is connected across a resistor, the current lead the voltage in the phase, the current lag behind the voltage in the phase, the current and voltage are in the same phase, the current and voltage are out of phase. So students, as from the earlier knowledge, what we have know, in the case of only resistor, the current lag behind the voltage. So the correct answer for this question is 2. Next, transformer are used in DC circuit only, AC circuit only, both AC and DC circuits, integrated circuits. The correct answer for this question is AC circuit only. Next, the magnitude of the EMF across the secondary of a transformer does not depend on the number of turns in the primary, the number of turns in the secondary, the magnitude of the EMF applied the primary, the resistance of the primary and the secondary. The correct answer for this question is option 4, the resistance of the primary and the secondary. Next question we have, in the case of AC circuit, Ohm's law holds good for peak value of voltage and current, effective value of voltage and current, instantaneous value of voltage and current, all the above. So the correct answer for this question is all the above. Next question we have, in an AC circuit having resistance and capacitance, EMF lead ahead of the current, current lag behind the EMF, both the current and EMF are in the same phase, or current lead ahead of EMF. If the circuit having resistance and capacitance. For that scenario, we know the correct answer for this question is 4th, that is, the current lead ahead of the EMF. Next question we have, an inductance L and capacitance C and resistance R connected in the series, an AC source of an angular frequency omega. If omega is greater than 1 by LC, then EMF lead the current. Both the EMF and the current are in the same phase or a phase. Current lead the EMF. EMF lags behind the current. The correct answer for this question is option 1. EMF lead the current. Next question we have, the EMF and current in a circuit are such that E is equals to E naught sin omega t and I is equals to I naught sin omega t minus theta. This AC circuit contains R and L, R and C, only R, only C. The correct answer for this question is R and L. Next question we have, an inductor coil having some resistance in connected to an AC source. Which of the following have a zero average value over a cycle? Option: induced EMF in the inductor, current, both 1 and 2, neither 1 nor 2. The correct answer for this question is both 1 and 2. Means induced EMF in the conductor as well as the current. Next question we have, in the case of AC circuit, the relation V is equals to IZ, where Z is impedance, can be directly applied to peak value of voltage and current only, RMS value of voltage and current only, instantaneous value of voltage and current only. Both 1 and 2 are true. So the correct answer for this question is both 1 and 2 are true, like peak value of voltage and current only and RMS value of voltage and current only. Next question we have, consider the following two statements A and B and identify the correct answer. A, at resonance of LCR circuit, the reactance of the circuit is a minimum. The reactance of the capacitor in an AC circuit is similar to the reactance of a capacitor in a DC circuit. A is true but B is false. Both A and B are true. A is false but B is true. Both A and B are false. The correct answer for this question is A is true but B is false. Next question we have a statement. The reactance offered by an inductance in AC circuit decreases with increase of AC frequency. Statement B. The reactance offered by the capacitor in AC circuit increases with increase of AC frequency. The options are A is true but B is false. Both A and B are true. A is false but B is true. Both A and B are false. The correct answer for this question is both A and B are false. Next question we have a statement A. With increase in frequency of a AC supply, inductive reactance increases. Statement B. With increase in frequency of AC supply, capacitive reactance increases. Options we have A is true but B is false. Both A and B are true. A is false but B is true. Both A and B are false. The correct answer for this question is 1. Next question we have, choose the wrong statement of the following. The peak voltage across the inductor can be less than the peak voltage of the source in an LCR circuit. In a circuit containing a capacitor and an AC source, the current is 0. At the instant source, voltage is a maximum. When an AC source is connected to a capacitor, then the RMS current in the circuit gets increased if the dielectric slab inserted into the capacitor. In a pure inductive circuit, EMF will be in the phase with the current. The correct answer for this question is, in the pure inductive circuit, EMF will be the phase with the current. Next question we have, select the correct option among the following. In an RC circuit, instantaneous AC is given by I is equals to I naught sin omega t plus phi. B. The alternating current in the circuit leads the EMF by a phase angle phi. Its impedance is R square plus omega c whole square to the root. Its capacitive reactance is omega c. Options are A, B are true, B, C, D are true, C, D are true, or A, C are true. The correct answer for this question is A, B are true. Next question we have assertion reason based. Assertion: a transformer can't work on DC. Reason: DC change neither in magnitude nor in direction. We have these options. Assertion, reason are true. Reason is a correct explanation of A. A, R are true. R is not the correct explanation or reason for A. A is true, R is false. A is false, R is true. The correct answer for this question is assertion and reason both are true, and reason is the correct reason for A. Next question is again based on the assertion reason. Assertion: in the series LCR circuit, the resonance occur at one frequency only. Reason: at resonance, the inductive reactance is equal and opposite to the capacitive reactance. These are the options. The correct answer for this question is option 1. Assertion, reason are true, and reason is the correct reason for A. Next question we have assertion: more the turn, more the resistance. Reason: impedance of the primary and secondary in the transformer is directly proportional to the number of turns in the coil. We have these options. Assertion and reason are true. Reason is the correct reason for A. Assertion are and reason are true, and reason is a not correct reason of A. A is true, R is false, A is false, R is true. The correct answer for this question is the first. A, R are true, and R is the correct reason of A for A. Next question we have: alternating current cannot be measured by direct current meters because alternating current cannot pass through an ammeter. The voltage value of current of complete cycle is 0. Some amount of alternating current is destroyed. The ammeter peak value of a current is 0. The correct answer for this question is the average current for a complete cycle is 0. The RMS value of a potential due to the superposition of a given two alternating potential, E1 is equals to E naught sin omega t and E2 is equals to E naught cos omega t will be E naught to E naught root 2 0. The correct answer for this question is E naught. Solution: we know that E is equals to E1 square plus E2 square plus 2 E1 E2 cos phi. Phi is equals to pi by 2. So after putting all these values, we get the relation. Now, 34th question is, if the instantaneous value of a current is I is equals to 2 cos omega t plus theta ampere in a circuit, the RMS value of a current in ampere will be 2 root 2, 2 root 2 and 0. The correct answer for this question is root 2. Next question we have, if a capacitor is connected to two different AC generators, then the value of a capacitive reactance is directly proportional to frequency, inversely proportional to frequency, independent of frequency, inversely proportional to the square of frequency. The correct option for this question is inversely proportional to frequency. Next question we have, in general, in an alternating current circuit, the average value of a current is 0. The average value of a square of a current is 0. Average power dissipated is 0. The phase difference between voltage and current is 0. The correct answer for this question is the average value of a current is 0. Next question we have, same current is flowing in the two alternating circuit. The first circuit contains only inductance and the other contains only capacitor. If the frequency of the EMF is increased, the current will increases in first circuit and decreases in the other, increases in both circuits, decreases in both circuit, decrease in the first circuit and increase in the other. The correct answer for this question is fourth. Next question we have, ratio of impedance to capacitive reactance has no unit, ohm, ampere, Tesla. The correct answer for this question is no unit. Next question we have, an inductor while having some resistance is connected to an AC source. Which of the following have a zero average value over a cycle? Induced EMF in the inductor only, current only, both 1 and 2, neither 1 nor 2. The correct answer for this question is both 1 and 2. Next question we have, the current does not rise immediately in the circuit containing inductance because of the induced EMF, because of the high voltage drop, because of low power consumption, because of Joule heating. The correct answer for this question is because of induced EMF. Next question we have, a capacitor is connected to an AC circuit. Then the phase difference between current and the voltage is pi by 2 minus pi by 2, 0. The correct answer for this question is pi by 2. Next question we have, a capacitor of a capacity C is connected in AC circuit. If the applied EMF is V is equals to V naught sin omega t, then the current is I is equals to V naught by L omega sin omega t. I is equals to V naught by omega c sin omega t plus 5 by 2. I is equals to V naught c omega sin omega t. I is equals to V naught c omega sin omega t plus 5 by 2. The correct answer for this question is fourth. Next question we have, at low frequency a condenser offers high impedance, low impedance, zero impedance or impedance of a condenser is independent of frequency. The correct answer for this question is a high impedance. Next question we have, in an AC circuit having resistance and capacitance, EMF lead ahead of the current, current lags behind the EMF, both the current and EMF in the phase, current leads ahead of the EMF. The correct answer for this question is current lead ahead of the EMF. Next question is, a choke coil is preferred to a rheostat in AC circuit. It is increased power, it is increased current, it consumes almost zero power, it increases voltage. The correct answer for this question is it consumes almost zero power. Next question we have, the in-current statement for LCR series circuit is, the potential difference across the resistance and applied EMF is always in the same phase. The phase difference across the inductive coil and the applied EMF is 90 degree. The phase difference between the potential difference across the capacitor and potential difference across the inductance is a 90 degree. The phase difference between the potential difference across the capacitor and potential difference across resistance is a 90 degree. The correct answer for this question is third. That means this is an incorrect statement. 47th number question is, the essential difference between the DC dynamo and AC dynamo is that AC has an electromagnet but DC has a permanent magnet. AC will generate a higher voltage. AC has slip rings, but the DC has a commutator. A dynamo has a coil wound on a soft iron, but DC dynamo has a coil wound on a copper. The correct answer for this question is AC has slip rings, but DC has a commutator. The unit of impedance is ohm, mho, ampere, or volt. The correct answer for this question is ohm. Like reactance, impedance, and capacitance. These are some have special units. Like impedance is the same unit as a resistance have. The power factor of an AC circuit having L and R connected in series to AC source of angular frequency omega is given by, we have these options. So the correct option for this question is R by under root R square plus omega square L square. Next question we have, the capacitor offers zero resistance to DC only, AC and DC, AC only, neither AC nor DC. The correct answer is AC only. Power factor is defined as apparent power, true power, apparent power, true power, apparent power square. Apparent power divided by true power is the first one. True power divided by apparent power is the next one. Or true power multiplied with the apparent power. So this is a formula. And the correct formula for this question is true power divided by apparent power. Transformer. Now all these questions come related to the transformer. A dynamo creates an electrical energy, convert mechanical to electrical, convert electrical into mechanical, create mechanical energy. The correct answer for this question is convert mechanical energy to electrical energy. Which of the following remains constant in the case of a transformer? The correct answer for this question is a frequency. The core of the transformer is laminated so that energy loss due to eddy currents may be reduced. Rusting of the core may be prevented. Change in the flux may be increased. Ratio of the voltage in the primary to that of the secondary may be increased. The correct answer for this question is energy loss due to the eddy current may be reduced. Next question we have, a step-up transformer is used to increase current and decrease voltage. To decrease current, increase the voltage. Increase the current and decrease the voltage. Decrease the current and decrease the voltage. The correct answer for this question is decrease current, increase the voltage. A transformer changes the voltage without changing the current and frequency, without changing the current but changes the frequency, without changing the frequency but changes the current, without changing the frequency as well as the current. The correct answer for this question is without changing the frequency but changes the current. Next question we have, a step-up transformer is connected on the primary side to a reachable battery which can deliver a large current. If the bulb is connected in the secondary, then the bulb will glow very bright. The bulb will get fused without changing the frequency but change the current. The bulb will not glow. The correct answer for this question is the bulb will not glow. Next question we have, the ratio of the primary voltage to the secondary voltage in the transformer is N. The ratio of the primary current to the secondary current in the transformer is N. 1 by N square or 1 by N square. The correct answer for this question is 1 by N. In the step-down transformer, the number of turns in the primary is greater than the number of turns in the secondary, less than the number of turns in the secondary, equal of the number of turns in the secondary, either greater or less number of turns in the secondary. The correct answer for this question is, as I told you in the earlier, step up means first number of a turn less and the last number of turns like secondary high. And step down, first number of turns will be high and the second number of turns will be less. So the correct answer for this question is greater than the number of turns in the secondary. Sixteenth number question is, a transformation ratio of a step-up transformer is ratio of turns in the secondary turns in the primary greater than the 1, ratio of the turns in the primary to the turn in the secondary is less than 1, ratio of turns in the secondary to the turns of the primary is less than 1. The correct answer is the first one. Next question we have, to reduce the iron loss in the transformer, the core must be made up of the material having low permeability, high resistivity. High permeability, less resistivity, or high resistivity. Low permeability, low resistivity, high permeability, low resistivity. The correct answer for this question is high permeability and high resistivity. Next question we have, a transformation ratio of a step-up transformer is greater than 1, less than 1, less than 1 and sometimes greater than 1, greater than 1 and sometimes less than 1. The correct answer is greater than 1. Next question we have, a step-up transformer develops 400 volt in secondary coil for an input of 200 volt AC. The current in the transformer is stepped up, stepped down, same but with the reverse direction. The correct answer for this question is stepped down. Now next question we have, the magnitude of the EMF across the secondary of a transformer does not depend on the number of turns in the primary, the number of turns in the secondary, the magnitude of the EMF applied to the primary, the resistance of the primary and secondary. The correct answer for this question is both. Next question we have, consider the following two statements A and B and identify the correct answer. In the transformer, a large alternating current at low voltage can be transformed into a small alternating current at a high voltage. Energy in current carrying coil is stored in the form of magnetic field. A is true but B is false. Both A and B are true. A is false but B is true. Both A and B are false. The correct answer for this question is both A and B are true. Next question we have a statement. Flux leakage in the transformer can be minimized by winding the primary and secondary coil one over other. Statement second. Core of the transformer is made of soft iron. A is true, B is false. Both A and B are true. A is false but B is true. Both A and B are false. The correct answer for this question is both A and B are false. Next question we have a statement. In high current low voltage winding of a transformer, thick wire is used to minimize energy loss due to the heat produced. Statement. The core of any transformer is laminated so as to reduce the energy loss due to the eddy currents. A is true but B is false. Both A and B are true. A is false but B is true. And both A and B are false. The correct answer for this question is second. Next question we have a statement. Step-up transformer convert low voltage high current to high voltage low current. Statement B. Transformer work on the both AC and DC. A is true but B is false. Both A and B are true. A is false but B is true, or both A and B are false. The correct answer for this question is A is true, but D is false. AC transformer works only with the AC, not with the DC. Next question we have, match the following. Step up transformer, step down transformer, ideal transformer, and the number of turns. Like these are the form. So as here I just want to elaborate these things little bit. Step up, number of turns in the primary and number of turns in the secondary. Step up, primary less, secondary more. So this. Okay, step down, primary less, primary greater, secondary more, and according to this you can say. So we have these option. So according to like correct option, you can match it down A with E. That means we can say that both is the correct one. Next question we have a statement. A transformer can't work on DC. DC changes neither the magnitude nor the direction. Statement 1 is true. Statement second is the true. Statement second is the correct explanation of a first. Statement 1 is true. Second is true. Second is a not correct explanation of first. Statement 1 is true. Statement second is the first. Statement first is the false. Statement second is true. The correct answer for this question is statement 1 is true. Statement second is the true. And statement second is the correct explanation for the one. Last question we have is statement 1. More than turns, more the resistance. Second statement, impedance of the primary and secondary in a transformer is directly proportional to the number of turns in the coil. Statement 1 is true. Statement second is true. Statement second is the correct explanation for a first. Statement first is true. Statement second true. Statement second is not the correct explanation for the first. Statement first is true. Statement second is a false. Statement first is a false. Statement second is a true. So the correct answer for this question is statement first is true. Statement second is a false. Maximum efficiency of a transformer depends on. These are the options. The correct answer for this question is whether copper loss is equals to iron loss. So this is all about the today's in this session. I hope you liked and you have did the more practice with the concept as well as the command on the practice part also. So thank you everyone for watching this video. Take care.